talking so much about this chapter, so let's take a look what we are going to learn on this chapter. So simply two-part, OSI reference model and TCP/IP model. So OSI reference model is the, you could all see from the name, it's a reference model. It's not in the real case, it's not in the real use, but it's built the standard structure, the standard architect for all computer network. So this is the protocol type of model of a computer network. So we're going to learn this model at first and transfer to the TCP/IP model upon learning this one. So let's go through the first part, OSI reference model. So also back to the question, what is OSI reference model? What it is? So the reference model defines the layers of structure the network devices must comply with. So how to comprehend this, how to understand this is, so if you do not have the knowledge, computer network knowledge, so you will see this this definition a little bit hard to understand, right? So defines a layered structure that network device must comply with. So that means all the devices, all the network devices must work under this structure, right? We all know that. So how to comprehend this in a more specific way? So personally, sorry, not personally, to me, I'd like to understand, comprehend this sentence by imagining, imagining that I'm doing some, I purchased something on the internet. I like to think this. I like to think this in this way. Just like an example. For example, just imagine we buy something on the internet. For example, if you could buy something on Amazon or buy something eBay or no matter what it is. So, but you buy something on the internet. So, in order to fulfill this purchase, there must a series of steps, right? Series of steps. They're gonna somebody on the internet to confirm with your purchase, with your deal, and confirm with your information, where to deliver this product for you, how much is it, how do you want to pay? So this is the one who confirm with the with the deal, right? With the deal. So after that, there must someone to work on the stocks. So if after you buy that product, buy that product, so there must be someone to provide to check with the stock and provide the storage, check the storage, check the dock, provide the product, and do the recording work. So this is the second part, right? So also someone need to arrange the logistics. There's so many steps. After that, upon all their works, the series works, your product will be the thing you bought will be sent out by logistics, right on the way, and transferring to your hand. So the purpose I say in this example is it works just similar as OSI reference model, because we're talking about, if we say we see that a network device is just like the Amazon, what Amazon just did just now. So the device also have different stages, different steps, right? They need to fulfill different kind of works to finish the job, to deliver the information onto the internet, to do the same thing. So how the network device do the thing? You can just imagine they do this job like the Amazon's personnel, right? They divided this job into different roles, into different steps, and different person in charge of his own part, his own steps. So the network devices is the same. So OSI reference model define the define the jobs or define the steps by different layers. So every layer do one or specific several jobs. And all these jobs, after finish all these jobs, the information you want to send out will go onto the internet or go onto the circuit network, right? So this is what OSI reference model defines. So you know it's layered structure. So what is layer structure? And the layer structure define the jobs. And the networks, the network devices all follow this structure to finish their jobs. So this is the example I mentioned just now, right? You just thinking, imagine that like you buy something from Amazon. Okay. So the benefit of the layered structure, the most important one is standard, the standard interface. Standard interface means after the OSI reference model appears, right? So all the network devices comply with the structures. That means the communication between the devices all follow the structures. So it's provide a standard structure, standard interface, standard language between the network devices. So we know since we have the common language, we can communicate. So that's the important feature of the or the benefit of these layered structures. Also, it says enable the compatibility between vendors, of course, because we say that we're saying the same language, right? Same language, no matter what vendors also using these standard structures, just like people from different countries, just like us. But we are doing this teaching all by English, no matter what our mother tongue is, right? So this is just, this OSI reference model, just like the English we're using right now. They provide a standard interface. They let the different vendor share the compatibility, right? So the third one is easy to learn, understand, and update protocols. So also combined with this one, I'll mention the last one. Easy to learn, understand, also easy to do troubleshooting. So how to understand this? When we learn, because this is the word I mentioned before I start this chapter. When we learn the following chapters, the following protocols, we look at time to time because we need to know the protocol based on the OSI reference model. We need to know which layer the protocol belongs to, the protocol exists. We also know the protocol's structure according to the OSI reference model. So that's why it's easy to understand. And for troubleshooting, when we do the troubleshooting, or when you guys do the lab experiment, you see when you find some trouble, the quickest way to solve the problem is to check layer by layer from physical layer, from the layer from the downstairs layer to the upstairs layer. So this is the quickest way for you to check whether your experiment why your experiment went wrong. So this is the whole thing, the benefit that a layered structure provide to us. So maybe this is a little bit abstract for us. So let's take a look at the real definition, right? Real definition. In OSI reference model, is divided into the network into 7 layers. So the figure is important, 7 layers in OSI reference model. By the way, in TCP/IP model, which imitate the OSI model, there's 4 layers. Just like a preview, right? So TCP/IP model is a 4-layer. It's just out of the OSI model. For the standard one, for the standard protocol prototype, OSI reference model is 7 layers, right? This figure. And when we're teaching about this layer, we talk from layer 1 to layer 7 in this sequence. So it's a physical data link up to application layer. Let's take one by one. So For physical layer, you said just a bit stream transmission. So it's easy to comprehend because no matter what kind of device we use, no matter it's a mobile phone or computer or a laptop or a tablet, no matter what you use, the last thing you transmit on the network or transmit in the physical world is the high-low digits, which is the 101010. So that's the physical layer do. The physical layer deal with the bit stream transmission, only with the bit stream transmission. So this is a physical layer do. And data link layer process with the media access and the link management. So this means when we learn the switching and the routing part, we will have a more detailed impression about this layer. But for now, we just understand so this layer is built based on a physical layer and is processed information that encapsulated on the physical bit stream. So it's like a hardware between for example, for two devices, they communicate finally by bit stream. But for the data link layer, they communicate with each other with more information about media and what kind of connection you have and what's the link you have. So this information deal with layer number 2. It's a data link layer. So it's like a media between layer 1 and layer 3, because layer 3 processing with the information about address, where you are and how to find you. So we can see, well, network layer is already very logical information. It's a logical information. It's have no, barely have relation with physical one. So that's what we call data link layer. It's just the media or the bridge between network layer and the physical layer, because physical layer is a physical one, but the network layer is about where you are and how to find you. It's a logical one. So between the physical and the logical, you need a bridge. So this bridge, the information on this bridge will be carried by data link layer, right? So one more step is the transport layer. Transport layer deal with the information of the how to build connection, but how we understand connection. So let's say that you and me are going to have a communication. So the network layer deal with the information that how can I find you? How can I find you? So after I find you, I need to tell you that I'm going to have a talk with you. So this talk will be carried on a connection. That means I find you already, so I find your address already. So for example, I need to talk to you. I need to make a phone call, right? So this connection is like a phone call. So I call you, I found you. So I carry information through this. I'm not throwing anything directly to you, but I need to talk to you by a certain kind of connection. So this connection building or establishment is based on transport layer. After that, session layer, presentation layer, and application layer is more and more closer to user's view. So that more about how your conversation will do, right? After building the connection, so it's the real case, the real communication. So what's your language you're using, right? How you gonna present yourself, right? Whether your information is in some kind of encrypted information or not. So finally, so what's the real information you're talking to me? So what kind of use? What kind of information carrying in your connection or in your what kind of information in your talk? So this 3 layers, 5, 6, 7 is more closer to user view. So this one, the transport layer is about connection. Network layer is about finding the path to finding the path or finding the route. And data link layer and bit layer is more closer to physical layer, and they deal with the information on basic level. So this is the standard model for 6 layers. And then we look at a very important page of the peer-to-peer communication. So on this page is we will call is the peer-to-peer communication, right? In order to explain this page, actually, we need to take a look at this picture very, very carefully, So let's do this together. The first thing into our eyes is that there are 2 hosts, right? 2 hosts connected by one, maybe this is a cable, Ethernet cable, is or anything, any media is okay. So these 2 hosts are connected together, and they need to communicate with each other, right? Communicate with each other, and we can say in order to finally understand what each other is saying about, what each other are talking about, they need to go through from layer 7 to layer 1 and back to layer 1, from layer 1 to layer 7. So every layer do its own job or do his own job, right? Mentioned just now. Let's take one. This is their jobs, right? One step back. So this mention is their job. So every layer deal with their own job, and they communicate with each other on their level, on their layer, or on their level. So on this map, we could see application layer using the APDU to communicate with the application layer of the host B. Host A's application layer communicate with host B's communication layer by APDU. Presentation layer, host A's presentation layer communicate with presentation layer of host B by PPDU, and so on, right? And so on. So this picture shows us the communication between 2 hosts are carried out by layers. Every layer only communicate with their peer layer. For example, application layer will not communicate with the presentation layer of the host B, right? They also not communicate with session layer. They just communicate with their application layer, and each layer do the same thing, right? They all only communicate with their peer by different kind of PDU, right? PDU is the protocol data unit, right? PDU. So the name is important. The name is important. So APDU, PPDU, SPDU, and from transport layer is called segment. The network layer is called packet. Data link layer is called frame. And finally, on physical layer is a beat. So how one more step to comprehend this. Let's say we sending host A and host B are sending email to each other. So application layer, for example, application layer is Outlook, right? Outlook. When A wants to send an email to host B, they need to go. You need to tap on the keyboard, or you need to find Outlook, right? But Outlook at first is definitely not a browser, not IE. You need to find Outlook, right? So because you want to send an email. So the application layer is the Outlook. And you send your information in the email and click send, right? Then the application layer Outlook will do the presentation work, and do the session job, right? To transfer the information that you need to present to your peer, present to the host B, and one layer down to build a connection with each other by segment, and one more layer down to find a path to find host B, from A to find host B. Oh no, the address of host B, and then finally send it out by physical bit string, right? Bit string. And to host B, steps that the host B do the opposite job again, just like host A did, just do that in an opposite way. So host B received the physical layers information, or is it called beat, and took off the unnecessary information and passed to the data link layer, and deliver to network layer, find, oh, this is for me, the information is for me, it's not for somebody else, right? It's not for host C, it's for host B, and then recognize the connection is also for me, and one by one, finally, it's got to the application layer, right? And got also the Outlook or the email kind of app, right? Email kind of application. So then host B's user will see the email on his laptop, on his desktop. Okay, this is uh, this is how the whole thing, how the peer-to-peer communication do to finish the one job, to send an email, right? So we can see all the layer communicate with each other on its own layer, right? Because for example, Outlook email send an email, Outlook application receive the email, right? And presentation layer do the presentation job, and the presentation layer explain the presentation job. So just like one job ahead and do the reverse job to get the information on the peer. So this is what we call peer-to-peer communication. So by now, I start to have a questions for you. So on this page, we already see every layer has its own protocol. They communicate with each other on their layer. So my question, let's take a look at another slide. So my question is, by seeing this picture, did you guys find any difference between the different layers? Any difference on the picture when talking about peer-to-peer communication?
We cannot see the picture.
Let's move back. This picture, let's take a closer look again. So we can see some, of course, the name of this layer is different. Of course, the APDU, BPDU, SBU, this expressions are different. So what other difference you can find on the picture? Hint, one more hint, please pay attention to the icons.
One thing, the sender is encapsulating and the receiver is decapsulating. Let's say the sender is converting FPDU to PPDU and then to SPDU and segment, packet, frame, bit, and the receiver is then reconverting that bit, frame, packet, segment, FPDU, PPDU, and then the actual data.
There will be two-way communication.
Okay, we can see this one by one. So, oh, sorry. So on this picture, we could see 7 layers. They talk with each other on their level, on their layer, and the difference, besides the name of this packet, the name of this information are different. So what is other thing you can find on this picture?
Additional header is there for each layer.
Pardon me?
Additional header. Each layer adds
Additional
header.
header. Additional header. On this picture, could you find any header information?
There's no header information. This is the basic information.
I mean, okay. In this picture, in this exact picture, of course, there are header information.
Yeah, there is a permanent line between a physical layer, and there are dotted lines between other layers.
I think that's the point. That's the point that we are looking at this question. That's the correct point. So let's check the checkbox. Different protocol on each layer, dotted line and normal line. So this one is the one I'm looking forward to. Dotted line and a normal line.
I think that the layers other than the physical is working on a logical, and the physical layer is working on physical instances, and maybe.
Yes, thank you. Thank you. Appreciate your answer. I think your answer is correct. No matter you say, I find that the different layer, this is dotted line, and this is a real line. This is a dotted line, right? Or you say this is the real communication. This is the logical communication. Both answers are correct. Both answers are correct because the dotted line and the real line is the purpose. They use the different lines, right? Dotted lines and real line, right? So this picture, because we already found a difference on this picture, right? The other 6 layers all do the peer-to-peer communication with a dotted line expression. So that means that all the other 6 layers are doing the peer-to-peer logical communication. They don't send their information directly to the opposite layer. So for example, application layer do not send APDU actually to the application layer of host B. No, they don't send this kind of information. Also, even to segment, to packet, to frame, this layer do not send the thing to the opposite side. For real. They're just doing what we call, or just you mentioned this is called logical communication. This is the logical communication. So why this is are different with the bit? Because the final, no matter what kind of layer and what layer do what did this layer did, and the final information will be encapsulated onto the physical layer, changed to bit stream, and sent to the opposite side, which is host B, right? And the host B, after receiving the information, host B will de-encapsulate one layer by another, and to let the 6 layers upstairs to know the information correspondingly, right? So the real information being sent on the line is bit stream, but every layer on host B receive the information after the downstairs layer preceding the information and pass the information to this layer. Every layer know the information logically. So logically, if we see this device doing the communication peer-to-peer, logically, the data link layer of host B received the frame from host A. Logically, network layer received the packet from host A, and so on. They all logically got the communication. They are logically received the information, receive this information logically. But if there's a question mentioned about if the frame is standing on the line, it's not correct, right? Because the only thing standing on the line or running on the line is the physical one, is the bit stream. So then it's our work, or it's our job to understand what is the communication, how the real communication happened. It's not only limited to logical one, but how the real communication happens, right? So this is the next page. The information on next page is the data encapsulation and the data de-encapsulation. So this explains how the host A and host B doing the peer-to-peer communication to each other, no matter logical one and physical one. So let's take a look. Let's say on this page, on the left side is the host A, and on the right side is host B. So just by using the same example that we just imagined, they sending an email between each other. So if the user on host A sending this email, after writing the email, press send, and Outlook application will work, right? And what this application will do? the exact action the application will do is to put a layer 7 header, or we can also call it a APDU header. It's also okay because it's a logical one. This is the header information, right? So that this header is added by Outlook, and the header plus the information. This information is the user, right? User write an email. So the information or the content of the information is the data, but the header is from Outlook. So this is the layer 7 header, and this layer 7 header plus data is called APDU. That's the logical this logical data unit. We call it APDU. And then after doing so, the application layer will pass it down to a presentation layer. Oh, because we don't know what is the actual presentation layer is on a computer, so we just say it's a presentation layer, right? It's maybe it's Outlook, maybe it's not, but it's on the computer. It has a presentation layer, and his job is also to add the layer 6 header onto to the APDU, and we call this as a PPDU, right? This is a PPDU, and so on and so on. The session layer needs to add its own header. It's called SPDU, and for transportation layer, for TCP or UDP, they add their TCP or UDP header. It's a layer 4, and we call this a segment. And pass down to the network layer to add IP header. IP header is a layer 3 header, and pass down to data link layer to add if the data link use the Ethernet. If the Ethernet, they add Ethernet header. Ethernet header. But if it is not Ethernet, maybe it's a token ring or some other type of a data link network. So they add their own headers accordingly. So that's what data link layer do, right? It's between network layer and physical layer, between the real logical and the real physics. So it's just a bridge, like what link are you using? What type of network are you using, right? You're using Ethernet as add Ethernet header. You're using a token ring as a token ring header. This is what data link layer do, right? So this is what we call a frame, right? And then finally, on the physical layer, in order to send this information out, to send this frame out onto the cable or onto the physical line. So add the layer 1 header. So this part is what we call a bit stream or bit data, binary data. So this data, this bit stream data, physical layer data, will be sent through the line for real case. This information is transmitted online, and after receiving the binary data flows from host A, so on host B, every layer do the opposite, de-encapsulation job to find their own PDU. For example, find their own frame, so find their own packet, find their own segment, SPDU, PPDU, APDU. So logically, although the real information are sent by binary bitstream on physical line, but logically we can see, after the de-encapsulation, every layer receive their own PDU, their own information, right, from the peer, from their peer, logically, right? So that's why we call this the peer-to-peer information, peer-to-peer communication, right? Because they only after the downlink layer de-encapsulate the header, they can get the information that this layer could understand, and they understand this is sent from the logical peer, and they process the information, process the PDU, and pass up to the upper layer, upstairs layer. So one by one. So this combined with these two pictures, peer-to-peer communication, logical communication, and the physical communication, combined with this map, with this picture, we have a clear and it's a basic and clear understanding of peer-to-peer communication and how a sender of a computer and a receiver of a computer do. What will this sender and receiver will do when they are doing the communication with each other? So this is the basic and clear idea. I need you all to remember these two pictures together, and know the difference, right? Which one is logical, which one is busy, and what it will do. Just adding header and peeling header, right? Peeling header.